Okay, so we'll get started a little bit. Hopefully, if you guys slowly get your data packages, you'll be able to catch up pretty quick. But we're going to start off really simple and slow, and so it should be easy to catch up. So here I am in SMAK. Um, Lovely front page. One of the things you probably should do on the first time you install and probably every time you upgrade is to make sure that if you go to File, you want to set a temp file directory. Quite often, you might try to open a file after you've upgraded, and it'll kick you out right away saying, "I can't open a file," and it's because the temp directory hasn't been set yet. So what we do is, whenever we open a data file, I open up the HDF file that's been saved as data. I use that as a shared memory kind of space so that you can actually operate on your entire data set and not be limited by when I had a 32-bit Windows machine that could only operate with like 1 megabyte of data at a time. So it helps you access the data that way. However, because it's a shared memory area, if you do anything to your data, you would automatically corrupt your original data file, which I thought was bad. And so what we always do is whenever you open a data file, it copies that data file to this temporary area, and you only work on the temporary file until you save it. Therefore, you don't corrupt your original data, and everyone's a little bit happier about their data not disappearing. I ruined a lot of data files very quickly when I first started writing SMAK that way. So that's a very good idea. I just create some temp directory somewhere on my hard drive in my users area. Just call it temp, SMAK temp, stupid temp, any kind of temp you want. And you'll be good. And you'll see lots of these little working files here that get created as you open up data sets. If your hard drive ever fills up, you can always blow away these gigabytes of data files. Hopefully it won't be too much, but there you go. You get one for every data file that you open. Okay, so we are here. So we'll start by opening up. We're going to start first working with the JR data, which actually stands for Jasper Ridge. If you're from Stanford, you know that Jasper Ridge is the little hill right in our background right over here, above the hill here. And it sits right on a nice little serpentine soil ridge there. And so this is a little thin section that's made from a nugget of serpentine soil from just around the corner here. So you can either go to File and open a single data file, or you can go to the little Open button here, and you can navigate in that data file. We're in, oops, that's a little too far. You have your users meeting data here. I'm already ahead a whole other year thinking about next fiscal year, apparently. The JR folder, we'll open up the XRF data, and section 1 right here at 12 kV. And you get a nice, lovely red screen. If you want to look at one of the data, you can click on any one of these element channels here and see what it looks like. So here's the iron channel. You'll see that you get a nice profile here. Slide and turn here so I can watch my own screen. If you want to look at data, typically from SSRL, we have a warm-up pixel, I'll call it, as the stage is getting ready to move and enters the sample area. And so that very first pixel on the far left is abnormally high. If I double-click on the map, you get a XY profile that, of course, comes on the screen below me, not on the screen above me. There we go. And you can see that this pixel right here on the far left is really high. So here's a X profile, here's a Y profile. And that first pixel on the X overwhelms all the rest of the data set there. So that's kind of annoying. The way to get around that is to zoom in around it. You can use, I think it's the control key to do a little zoom like that. And I can right click to clear that zoom on that clear zoom. But if I want to do a quick one, I can just do edge removal. And this zooms in 1 pixel on every side. And it's like the data, that 1 bad pixel goes away, and everything's back to normal. That looks beautiful. So there's your quick edge removal. And now we can go through and take a look at the other data channels. You see there's some zinc, copper, some sulfur, potassium, a hunk of calcium on the corner, some lovely titanium streaks through there, some manganese, and there's an arsenic channel, but there's no arsenic there because we're at 12 K. Well, I guess there could be a little bit of arsenic there, just barely above the arsenic edge. There's some lovely chromium, nickel, and then the total counts and the outgoing counts. We also typically will give you a time channel. This is the amount of time spent at any 1 pixel by the detector. And it should be fairly uniform, which you see it's fairly uniform. But you can see there's a little, what you see is a little pattern here, and that's the wobble in the stage encoder. So that's actually part of the hardware. It tries to keep it at a constant speed, but it's got little frequencies as it goes through and rolls along the stage. And it's pretty reproducible as a function of position. But it's all, and the units here are clock ticks from the detector, which is a very helpful unit, of course. It also now will depend on what version of hardware we're using the beamline, but 1 clock tick is roughly 12.5 nanoseconds. So if you multiply by 12.5 times 10 to the minus 9th, you would get into seconds again. So this is even not a huge data set, but it's there. There are multiple things you can do. If you try to drag the size of the window, it usually doesn't make things any better. You probably know that. You can just zoom in. So I'm going to go to a data set here. If I zoom in, it will reproportion the window, and usually you can get enough in there to look at it. But what you typically want to do is go to View, and there's an Apply Scaling Factor. And you can go from about 1/10 of the size up to double zoom if you have a really small data file. You probably won't be increasing the size, but you'll probably be decreasing the size. And this will do everything except for the tricolor plots, I think. But that can help you manipulate things back on there. The most annoying thing typically is it is trying to fit the data image onto your screen typically to the best it can manage. And what it will often do that I find horribly annoying is that it fits the whole data image right to the bottom of the screen. And the part you want to access, changing the scale or the color map, is always off of it, and you can't get it up and higher and down and lower. So you have to either zoom in or change the scaling here. We're going to talk about a lot of little keyboard shortcuts. If you forget what they are, you can always go to the help screen, which then puts it on the wrong window again. And it gives you a little shortcut windows of all the common keyboard shortcuts and mouse shortcuts. And we'll be saying things like left click and right click. So we're trying to use all the possible mouse combinations that you can access. If you do have a SMAK thing, it's usually like a double button press for that left click. Okay. You can also, of course, see what version you have by going to the About. There you go. I'm always one version ahead of y'all because I'm running my test environment, so don't worry. I really have not done much in the last 10 days. It also does give you handy ways to get a hold of me again if you forget them. Lovely ways to reference the use of the Microprobe Analysis Toolkit. And if you are using things like the PyMCA or the FTIR processing, the appropriate references for those people as well. Make sure you give everyone proper credit for the algorithms that are due. They'd all appreciate the bump in their reference list as well. And I'm going to clear the zoom, make it big again, and go back to edge removal. Okay, so there's our beautiful data. Everyone's got this so far? Okay, excellent. So we've opened data, that's great. We can also visualize it in a tricolor way. So this is adding multiple channels together. The typical way to do this is it pulls up a lovely panel like this, and we can display, say, iron and red, since that feels very appropriate. Probably why I have to drag all my windows around here. And then we could add, what's the next person's favorite element? Do the chrome in green, since that should glow green, yeah. And maybe, just because I like manganese, put manganese in blue. Now the manganese doesn't show up very well, and then you can always say adjust your top end. So now I make this go to 165, and now the blue shows up much stronger. This is very similar to this concept here. If I grab the slider here and I drag down, you can see I can change my top end, and you can see different details. I never like publishing in like this because if I see huge areas that are oversaturated in the color map, I know that's being overly biased. But at least state that. It's also important, so I roll around, you can see the coordinates change, the X and Y coordinates, the horizontal and vertical parts of the map. You get a lovely Z coordinate there, which is the intensity of that element's photon counting at that particular pixel. So you can scroll around and get an idea of what the different intensities are. If you want to know that absolutely, we can go to the legend and say view color map. Of course, it's going to put it on the wrong screen for me again. So we can drag up. There we go. And this tells us that now that we're plotting intensities from 0 to 3645. If I adjust this top intensity, you can watch that change and the color scale change. I often will go to log scale. It makes a nice big log view of this as well. It lets you see some of the details and not wash it out too much. The default color map is jet, which is a very standard, boring, cool to hot kind of flavor. There are a few other color maps that are present, and a whole list of them. If you like a more color balanced one, you can go to the Viridis. This is nice because it has equal intensities across the range, so your eyes don't overly bias between the mid-range. The standard gamma is one that's popular as well. That's the standard one that comes out of the APS Maps viewer, if you're familiar with that program. Some people like different color maps. Everyone's got their favorite. I just tend to stick on jet to start with usually, so I'll stick back here. We're going to adjust this display here. That was a little bit too blue for the manganese. So something like that. And now we kind of see there. You can actually make the red a little redder. It all depends what you are looking to see. Again, that's another thing where you can really bias your presentation of the data. So I strongly advise that when you do publish graphs that you plot your scales, or at least tell the people what the scales are. If it's log, if it's linear. The worst thing is not seeing any kind of legend to your scale bars, to your images. Or certainly don't put me as a reviewer if you don't do that step. Once we have a window open here, if I do something like zoom, for me that's control, and zoom in around, you'll notice it'll snap the tricolor plot to the same region as well. And so typically in most of the windows here, they will all try to at least show the information from the same viewing area. So if you make a change in one, they'll all kind of snap together. Again, if I right click, clear, it'll pop out. I can edge remove and pop in again. Another thing is that, if you are trying to be sensitive to everyone in the room when you're making presentations, RGB is the common color scheme because it is easy to combine colors. That's how your monitors work in RGB space. However, you can, let's see, you can convert your palette to a cyan, magenta, yellow. Just rotates it from reds to combinations. It looks a little funky here, to say the least. But if you are colorblind, it should be mildly easier to see. We should have this plot update as well here. Doesn't, I'll have to realize that I made a mistake somewhere again. Yeah, there we go. Now we're rotated on that one too. So you can try to make things mildly more color friendly for viewing. It's a little harder to think sometimes. I have a hard time thinking in CMYK. But what colors combine to make other colors at least. I'm going to put this back. There we go. And there we go. Oops. Maybe we won't go back. It really wants that to be in that color scheme. We'll go with it for now. Okay. It did also update it up here, I hope. Yeah, so now you kind of see how that color scheme goes in Jet. Let's see if I can break it apart here. Oh yeah, that's beautiful too. Oh, still stuck. There we go, back to normal again. Okay. What else do we want to say about this? Got legends. You can always save these legends here under legend and saying save color maps. Same thing with a tricolor map. I'll give you a nice little triangle of your schemes. Another thing I always like to harass people about is not showing a scale bar on their graphs, on their images. So clicking on show scale bar will automatically put a scale bar, top left corner. It defaults automatically to the nearest round-ish number that is close to 10% of your horizontal scale. I have not given you much more flexibility than that, but it is usually sufficient for your data set to not be ginormously blocking the whole thing, and a somewhat useful area. And notice it puts it on this one too, of course, because you want scale bars in both. If you don't like where that scale bar is placed, under the legend, you can say place scale bar, and you can say, click on where you want it to be. I'd really like that right in the middle of my data set, because that makes a lot of sense, obviously. So there you go, there's your 400 micron scale bar. You can realize that that was not where you wanted to put it, and you'd like it to go back. And so you can just say under legend again, go back to default, and it'll put it nicely back in the top left corner.